Mic on.
Okay, up and running today too. I'm a bit lonely. I'm alone in Rome. There's no one here. All my friends are out of town. My girlfriend is out of town. All the restaurants are closed. All the shops are closed. It's very lonely. And it's very hot outside. So I'm here home on a Friday night streaming. Today I'm gonna work on the 5th chapter of this very interesting repository, which is centered on RankNTypes, the extension RankNTypes. I hope it will be a little easier than data kinds, or but at least as interesting. Let's see how it goes. So as usual, I'll go first through the explanation file very quickly, and then we go with the exercises. In Loop Vegas, module number 5, we'll be discussing higher rank polymorphism using the RankNTypes extension, and how a function can change entirely depending on where you put your quantifiers. Okay, let's start things off with a function to wrap the values of a tuple in maybe by applying them both to just. Okay. So you wrap two values inside of two maybes. No problem so far. Alright. The just function takes a value of any type A and returns a value of maybe A. Now this function is a bit specific. What we'd really like to do is pass in the wrapping function that takes any type A to A. Wait, I'm a little confused by these at symbols. It takes any type A to a FA for some F. Okay. No problem, we just introduce a couple more variables. So wrap any F and a tuple AB. Okay, I already know that this one doesn't work. It doesn't work because it tries to use the same A here and here. I mean, the wrapper just can be maybe int and maybe string at the same time. So we got an error. Gonna match type string with int. Okay. The function type checks, but the usage doesn't. Specifically, we get a type error. Yeah. Well, that's weird. Let's look at the type of wrap any. Wrap any takes a function from A to B, a tuple of two values of type A, and a tuple of two values of type B. What happened? The GHC type checker looks in the body of the function and sees that the same f is used for both A and B, and deduces that they must therefore be of the same type. After all, how else could it work? The problem is, of course, we know it could work, just should work. The problem, it turns out, is a little bit subtle. By turning RankNTypes, we have also enabled explicit for all, which allows us to write some syntax that might be familiar to PureScript users. So yeah, in PureScript you're forced to explicitly write your for alls. This definition says that ID will work for all types that A could possibly be. This is nothing special. GHC internally writes this for all for us when we write a function like ID from A to A. So what's the big deal? Well, let's just look at just. It's gonna be hard. So just is a function that takes for all A and goes from A to maybe A. Cool. Nothing too surprising yet. Now let's look at that wrap any again. So it goes for all A and B, takes a function and goes from A to B, a tuple of A's, and returns a tuple of B's. We want to introduce a new type parameter x. So we write a new wrap any. Let's try and commenting it. So it has four type variables, a, b, f, and x. It takes a function and goes from x to fx, tuple a, b, and returns f of a and f of b. Okay, it doesn't work. Couldn't match expected type x with actual type a. This definition still doesn't type check. Specifically, it's saying we can't unify x with a, which means we can call an xfx function with an a value. This makes sense. Imagine the following user call. Wrap an example. Okay. Which is a maybe int, tuple of maybe int and maybe strings. It goes wrap any. Yeah, of course. It's not possible because we are adding one to x, and then we can do this with the first part of the tuple, which is a number, and then with the second part, which is a string. Here, our user have chosen f to be maybe, a to be int, b to be string, and x to be int as well. There's the problem though. We can't use an int maybe int function on a string. What we need is a way of saying that the function must work for all types that we put in. So wait. So we have a wrap any new. And the difference is that it puts a for all x inside of the function. So this seems to type check. But why? Well, let's think through it. Consider the following signatures. ID for all A to A, const for all A, B, A, and map for all A, B, F, functor F. A function goes from A to B, and then takes an FA, returns an FB. Okay, these are all the functions that we usually use, so I'm very familiar with those. In all these examples, the signatures say that they will work for all types. In the case of map, we can give it an A to B and get back a function FA to FB, yeah, of course, for all A's, B's, and F types. What this means in practice is that we, as the caller, get to choose what those types are. Okay, so we call map, we are the caller, we're using map, and we're choosing what A, B, and F are. The function can know anything more about them than what's in the context. In the case of map, that it's a functor, because beyond that it could be anything. Yeah, this... Wait a second, sorry. I think it's a bit like the thing we saw with existential types in JDTs, where you can't do anything with the types. You can just it's not really the same. I'll stop even since it's something stupid. Let's go on. The problem with this is that the function never gets to choose one of the values for us. In the case of RankNTypes, what it wants from us is a polymorphic function that will, for all types, lift them into some context, like maybe. We need to give it a function that works for all types, so that it can choose which types to pass in. That's why the argument has a for all. Okay. This who gets to choose is a really good start intuition for our ranks work. So if we have rank 0, from int to string, no one gets to choose. Because of course we have no type variables. There's an int and a string and there's nothing to choose. If we have a rank 1, which is the usual common function we might use, I guess. And so we can write them as a for all A from A to A, the caller gets to choose. So the one who's using this function. In case of a rank 2 polymorphism, so if we have a for all A, then a function goes from A to a function that for all B's goes from B to B and then gets back in A, it's the call that gets to choose. This actually generalizes, although we won't see many examples of functions with higher rank than 2. Okay, it doesn't explain why it's the call that gets to choose here instead of the caller, sorry. So I'm using this function. I need to pass it an A, so I can choose what the A is. And then I have to pass it a function that for any B's returns another B. So yeah, I can choose what this B is, because this B can be anything. And it's this called function that has to choose what the called B is. Makes sense. Makes sense. For one last thought, let's think back to our existential JDTs. Oh, maybe I wasn't saying anything too stupid. So we have data showable where showable show a showable. Yeah. We say that to do anything with a showable, we'd have to supply a function that works for all types implementing show. In other words, we could write an unpacking function, unpack, which takes a showable and returns a string. Or we could generalize it to take any relevant function. Oh. What might the type look like, you ask? Exactly as we'd imagine. So it takes a function that for all A's with a constraint of show A, takes an A, returns an R. takes a showable, and then returns an error. Why is this an error, not string though? Interesting. I guess it's implied because the only thing we can do with this A is show it. We don't know what's in the showable. We just know it as a show instance. So in order to unpack it, we need a function that can express that. In reality, the first thing this function is going to do is show, but it won't always be that simple. The point is that we can use rank2 to require that the given function works for any type with a particular class interface. This is the pattern you'll see in an overwhelming majority of examples with rank2 types. We don't know what the value is, but we know about some constraint that it has. Get used to seeing signatures that look something like x goes to a for all a constraint a function from a to r, because we'll be seeing a lot of them. Okay. Let's go to the exercises, which I'm sure will be very mind-bending. We have 8 of them. Cool. There's no viewers tonight. It's a little sad. Probably not a lot of people home at the computer like me. Okay, I'm getting ready. Just a couple of things. Okay, so let's start with the first exercise. The following JDT creates a list of values of unknown types. Data existential, where we have a nil, which just return an existential. Oh, this is so hard to spell. Our accounts, which takes an A and existential and returns another existential. So A, write a function to unpack this existential into a list. Okay, let's try. It was so nice to already write the signature for us. So we can have a nil as a constructor, and I guess in this case we don't care about the function, and we can just return the empty list. In case we have accounts, gonna have value a tail, and we're gonna have this function f, and we can just do fa and append it to, or prepend it to unpack existential of a's. Does this work? Oh, it also needs the function. Yeah, it works. So this one wasn't too bad. Sorry, it's just
mic off. Mic on.
okay. Sorry. Regardless of which type R actually is, what can we say about the values in the resulting list? Nothing. We don't know nothing because yeah, we know that there's a function that is able to take these A's and returns R's, but we don't know what this function is. So we have no idea, I guess nothing. How do we get back knowledge about what's in the list? Can we? This is interesting question. I think we can't. Not super sure about this thing. Let's try doing something with this data type and see what we can do with it. Let's create an existential data type. So this could be counts 1, counts 2, counts 3, nil. Let's use chars. Otherwise, we'll start complaining that it doesn't know if 3 is an integer or whatever else. Okay. Now we want to unpack this. So I still don't know what's gonna be the type here. It's gonna be an unpack existential. Then I have to pass some function here. So of course we know that this is an array of something. So what rank is this function? Is rank 1, right? So I'm the caller and I get to choose the function type, but I don't know anything about the type. No, this is rank 2, right? Is it rank 1 or rank 2? I guess it's like this, so it's rank 2. So can we pass something like ID? Oh, sorry, X. Let's do this. Couldn't match type A with R. Yes. Oh, hey. What's up? So A and R can be the same type because one is chosen by the called and one is chosen by the caller. So we can use ID. And And I guess the only way we can, yeah, I'm good. And doing these RankNTypes exercises, which are, I already know the RankNTypes are hard to reason about. Oh, cool. What are you gonna be streaming about tonight? So I guess the only way we can have these work is by passing some constant value. Yeah, so we are the caller, and it's the called who gets to choose what this type A is, because this is a rank 2 function. So the only thing we can do, since we don't have no idea what this A is, and there's no constraint or anything, is just pass a constant value. What's an Haskell love vid? Is it a conference or something like that? So this is the only way we can use this function. I guess that if we add a constraint here, then we'd be able to do something different. We could probably pass show here.
This is, excuse me, a damn fine cup of coffee.
Oh, nice, interesting. I will have to look into it. Let me know if there's any interesting video that I should watch. Okay, so this wasn't too hard. Maybe because I already went through the Thinking with Types book from Sandy McGuire, which covers a lot of this stuff. But let's go back to our correct answer. So actually the answer is not nothing, but this is the correct answer.
Every day, once a day.
Yeah, thank you very much. Maybe I'll join later on. I don't think I'm gonna be streaming too long. Even though that's always what I think, and then I end up doing like 2 hours of me struggling doing these exercises. Okay, so number 2. Consider the following JDT that existentializes, these words are so hard, a foldable structure, but crucially not the type inside. Okay, so there is a data can fold of A, where there's only one constructor, which is canFold, which has a constraint foldable f. Text takes an f of A and returns a canFold of A. So A is not an existential variable, but f is. And we have a constraint on f. So we can definitely use A, and we can do something with f because we have the constraint. So we are not helpless. A, the following function unpacks a canFold. What is its type? Okay. So it's gonna take something, which I'm gonna leave as an underscore for now. Then it's gonna take a canFold of A, and it's gonna return something else. Okay, let's see if the compilers can help us a little. I think that we have too many underscores here yet. Okay, couldn't match expectant type. FA, okay, well, those are all underscores. This rigid column type variable is bound by a pattern we constructor canfold, which is a for all f. A foldable f, okay. So we can try explicitly writing the for alls. So we have a for all A outside here. Here we're gonna have a nested for all, making this rank 2 type, rank 2 function. And this one is gonna be a guess we keep the constraint foldable f. Yeah, it seems like when we have too many underscores, especially with type level programming, GHC just throws its hands up in the air. So you deal with it, I don't care. There's gonna be a foldable f and takes an A. Okay, wait, I'm very confused. Very confused right now. So wait, this x is not actually, it's actually an f of A, and we know that f is a foldable. So this function is something that needs to be able to work with foldables. So it takes an f, let's say returns a g, ff of A. Let's go 05 cabal, oops. Let's try info. Yeah, so foldable obviously only has folds, so we go from a structure that has that's inside of a foldable container, and we get back to a single value. We need a null here. Okay, these types checks. Let's go over it again. So we have an unpack and fold, which takes an f, which we know it's a function because we pass it to x as an argument, and takes a canfold of x. Canfold here, as we can see, its only argument is an f of A. So we know the type of A, but we don't know the type of f. We only know it's a foldable. So having said that, we know that we are applying f to x. So this function f has to be a function which takes a foldable f of A and returns something else. This variable is not in scope. Who's choosing this variable? Is it me? Is it the cold or is it the colder? So this one type checks. Does this type check? This one type checks too. I have no idea which of the two version is correct. Let's write both of them. Let's try them. Let's see if we can. Okay. Oh, of course, my bad. This g variable is also outside. It's not only inside of this function, obviously. So we can use this version. It's not correct. So we are the one choosing this g. Interesting enough. So let's go through the other points of the exercise, and then we'll try using this function somehow if it's not already one of the requirements of this exercise. Okay, B. Can we use unpack and fold to figure out if a can fold is empty? Okay, let's try. So length takes a can fold A and returns an int. So we have a can fold that holds a foldable structure. I guess we can just fold it. Oh, actually, there is a length function inside of foldable. Yeah, ambiguous, blah blah blah. Let's call it length. This actually works. Nice. Let's try writing a value. Can fold int. Does this work? Okay. Okay. So can we call length on our can fold? Why is it not scope? File to modules loaded. Yeah. Let's go with a stack rebel. Okay. Length of can fold. I got 4, it works. Write a foldable instance for can fold. Okay. So instance. Okay, the class foldable takes a type constructor, so we can pass can fold, where the minimal definition requires fold map a folder. Folder takes a function, accumulator, and our structure. And fold map takes function or structure. seems like it just works. Yes, works. So now we can just call length on our can fold, and we got the length. Nice. I'm gonna open this one, which has bigger font sides. Still haven't got into increasing the font size in my other term. Okay. So let's go to the third exercise. It's not too bad so far. Write a function that unpacks an EQ pair. Okay, so we have our EQ pair, which has an existential type A. We have the EQA constraint, takes two values of type A, and returns an EQ pair. Write a function that unpacks an EQ pair by applying a user-supplied function to its pair of values in the existential type. Unpack EQ pair. Oops. Just gonna take the function, an EQ pair. Oh, come on. Return something else. So this one takes a function that for all A's goes from A to B. Returns a tuple of B's. Yes, this will make sense. Unpack EQ pair. Takes a function, take EQ pair AB. Returns f of A, f of B. Okay, we have it. B. Write a function that takes a list of EQ pairs and filters it according to some predicate on the unpacked values. Okay, filter EQ pairs. So it takes a function that for all A's goes from A to bool. Takes a list of EQ pair. Write a function that takes a list of EQ pairs and filters according to some predicate on the unpacked values. Okay, so I think this is probably wrong for the type, but let's go with it and let's see how it goes. So as you can see, we have filter, which takes a function, goes from A to bool, returns, takes a list of A's, returns another list of A's. So we can definitely, okay, we're gonna have our values here. So we're gonna need to filter with something, our list. So this one has to be a function that goes from EQ pair to bool. So what we have unpack EQ pair, which is a simplified that's right all. So it's for all A's from A function that goes from A to B, an EQ pair, and a pair of B's. I feel like we have to pass a lot of stuff here, right? Because we need this transform function, and then we need a predicate that has to handle these values somehow, right? Okay, so let's try to do it as simple as possible. So we have a transforming function that we use with unpack. So we can put it here. And here we can do an unpack EQ pair F. This obviously won't type check because we have a tuple of B's and it needs bools. So I guess we could pass another function which goes from a tuple of B's to bool. And we can call it P. Then we can do a P dot unpack EQ pair F. So this one type checks looks a little convoluted. I'm not sure if this is the type that was wanted for the exercise. Write a function that unpacks an EQ pair by applying user supplied function to its pair of values in the existential type. I think probably what's wanted is this. It's not entirely clear what it means with unpacking, right? Could be anything. Yeah, but let's go with this version because I feel like it's a little simpler, makes more sense. So it was an if a b, and then this can become the predicate goes from A to bool, and then we can remove this one, and then it just becomes unpack EQ pair F. And this one works. Nice enough. We're gonna try it. See if everything is correct. C. Write a function that unpacks two EQ pairs. Now that both our variables are rank 2 position, can we compare values from different pairs? Not sure. Unpack two EQ pairs. For all A, B. It's not entirely clear with this exercise what the final type should be. If I have to follow what I did before, this will be a tuple of b's. So it takes a function f, an eq pair ab, an eq pair ab, and returns fab, fab. Oh, or more simply, pack eq pair fa and pack eq pair fb. Now that both are variables are in rank 2 position, I have no idea. What does it mean that both are variables are in rank 2 position? What are the two variables? What's the difference from here to here? It's still only age which is in rank 2 position. B is not. I don't know. Let's try writing some code to test or rot. Maybe we'll get to solution by doing this. So we have an AQ pair, which is an AQ pair 1, 2. Then an AQ pair 2, which is an AQ pair A, B. Okay. Now we want to unpack one, which is an int. Unpacked one could be a unpack EQ pair plus EQ pair 1, pack 2 string, pack EQ pair EQ pair 2, let's create another EQ pair because we to filter down they all have to be this of the same type. Filtered queues. It's gonna be this EQ pair. Oh, hi! Thanks for joining. Yeah, this is a very cool exercise. It's very interesting. They're not too hard and interesting enough. Yeah, they're very cool. Very cool. Okay, so we want to filter our list, so we can do a filter EQ pairs. I pass some function, and then we can pass EQ pair 1, EQ pair 3. So what's this function? This is a function that takes two A's and returns a bool. We actually don't know anything about. Yeah, me too. I went through like half of the book. My problem with those kind of things is that I tend to forget them pretty quickly because then I never use them. So having these exercises where I can try to apply these concepts again, it's very helpful to try and cement everything. So I guess the only thing we can do with filter EQ pairs is filter them by equality. Okay, we're getting some errors. Let's see what these errors are. Yes, of course, I can pass a plus because I don't know what A is. So how does this unpack EQ pair works if I have no way to know what the value is? I guess the only thing I can pass is the equality function. It's the only thing I can pass. We know that we have an EQ constraint here. We have an EQ constraint here. So this one type checks now. And I guess this one becomes a bool too. So types check. Sorry. And yeah. Exercises. Oh, there's no show EQ pair. Show. We can't derive it because there's existential variables. Well, anyways, I mean, there's no point to printing them. I'm like 80% sure that the only thing we can do with this unpacking is checking for equality, because A is the rank 2 variables, so we as the caller have no control over it. We can know what its type is. So the only thing we can do is leverage this EQ constraint. And I guess with EQ we don't have even like greater on or bigger to then, right? Yeah. So yeah, we can do equal or not equal. That's it. The only two operations we can do to unpack our EQ pairs. Nice. Yeah, I feel like I'm getting a little more comfortable with these concepts. Let's see how the next exercise completely crushed my confidence. So 4. When I was building PureScript Panda. What's PureScript Panda? I want to quickly check. Sorry. Panda is a PureScript UI library for building declarative frontends without a virtual DOM. To achieve these, dynamic events are specifically labeled and configured to produce specific event listeners. Okay. So, when I was building PureScript Panda, I came across a neat use case for RankNTypes. Consider the following sketch of a type. So we have a component which is parameterized over an input and an output. and has some sort of component stuff. Okay. Now let's imagine we want to add the constructor to nest a component inside another component type. Okay, this is exciting. I'll do this and I will go check Halogen source code and I will understand all of it immediately, I'm sure. So we need a way to transforming between our parent IO and child IO. So we write this type. So we have a data nested, which takes an input and output, a sub input and a sub output as parameters. And has one constructor which is nested, which has a record, which has an inner, which is a component parameterized over sub input and sub output, as an input, which is a function that goes from input to sub input. Okay, an output, so there is a way to let's thread the input to the subcomponent and grab the output from the subcomponent, I guess. So write a JDT to existentialize sub input and sub output. Okay. Where we are nested X. Inner is this correct? I hope so. Then we have input. Oh no, wait. Now this is a JDT. I'm sorry. So this takes a component and returns a nested X input output. Inner takes an input, a sub input, returns a nested X input output, and output takes a sub output to nested X input. I'm getting an error. Well, I'm getting an error. Oh wait. Actually, I have no idea. Yeah. I have no idea how to use records with JDT syntax. I don't think that's the error. How's it going, man? Does it have to be like this? Record syntax is illegal here. Yeah, actually, I think I never used record type with JDT syntax, so I'm a little unsure of how to do this.
Welcome to the program. I'm sorry. I thought the show was over. It started? Yeah. Oh, yeah. Okay.
I have to write the 3 separate constructors. Let's see if I can find some example. Why does it work here? Oh, foo goes from the record to the type. No, wait. Doesn't make much sense to me. Okay, these type checks. Looks very weird to me. I'm not sure if it's correct. Well, let's go on and see if anything explodes. Oh, if because you're interested. Yeah, me neither. Just follow this example here. Foo goes from a record to our types foo of a. So he used line 84 of Panda internal types. Internal types, line 84. It's not line 84 anymore. Yeah, it is not the case anymore, I think. This is not a JDT, this is not a JDT. Oh, wait, but this is pure script. I'm confused. Yeah, it's gonna be different syntax, so we can look at. Well, let's go with this and see. So write a function to unpack a nested X. The user is going to have to deal with all possible sub-inputs and sub-output types. Okay. I guess, I mean, it's probably I don't know, this one doesn't have sub-input and sub-output as existential types anymore, so I'm not sure. Maybe I can look into an older version. No. Well, doesn't matter that much. So we want to unpack this nested X. So we're gonna have rank 1 input and output. Now we're gonna have some kind of function. Gonna have a nested X input output. I'm gonna have some output. Which I guess we can call O for output. And let's put the O here. So this is gonna be some kind of function which is gonna have rank 2 sub input and sub output. And I guess it goes from nested X input output to O. Pack nested. Okay, this looks a little too simple. This looks way too simple. Obviously, there have to be some input and some output somewhere in this signature. This is very interesting. So do we have to write the whole signature of this thing? I don't want to write all this stuff for now. No, I feel like I'm going the wrong way. There's something definitely wrong here. Let's read all of it again. Let's imagine we want to add a constructor to nest a component inside another component type. We need a way of transforming between our parent IO and child IO. So we write this type. Nested input output sub input sub output. Okay, so we have no existential types. These are all specified here. We have the nested constructor, which is a record, which is an inner output, inner input output. Okay, write a JDT to existentialize sub input and sub output. We can reuse this component, maybe this data type. I think it's still type checking. Yes. So now this becomes unpack nested X, which has a rank 2 type sub input sub output, and now we have a Yeah, it does. I was ready to write a very long type signature here, and I thought maybe this is not what's been asked here. So I guess this function can just take a nested input, output, sub input, sub output, and return a no. And I can take nested x, input, output, and then returns an O. So we have function, nested x of n, just return f of n. Yes. So I get no error, I guess. So this one looks reasonable. C. Why might we want to existentialize the subtypes away? What do we lose by doing so? What do we gain? Feel free to give your opinion on this because I'm a bit lost. Why? Because they're hard? Because there's no clear answer? And they're open questions, so you never know if you answer correctly. Luckily, we can still check the answers, hoping that this will be answered. So let's go back. We had this stuff. So we had this component that had all the types specified. Yeah. So we have a nested component, which is defined by a sub input and sub output. We have a way to go from the outer input to the inner input. And we have a way to go from this inner output to the outer output. So by making these type variables existential, what we are doing is that we're not caring anymore about what the types of the nested component is, right? Because our parent component is only defined by its own input and output. Isn't this what happened with the change from knowledge 4 to 5, I think, where you had to specify all the subqueries, sub inputs of the child components, and now I think you don't have to do that anymore. We don't have to care about the subcomponent type anymore. I'm gonna check the answer at the end. 5. Let's continue with the theme of the last question. Let's say I have a few HTML renderable components. I like these exercises. These are very practical. So like they're teaching me something that I can use to write a library that no one will ever use. Yes, there's an answers branch. Sadly, for many chapters, these more theoretical open answer questions are not answered. They're only answers for the technical exercises. Yeah. So data first go. which takes an input and an output as parameters. It can be either a text string or an fhtml, which takes a tuple of strings, which are properties, and an array of children. Cool. This is very cool. Once I'm done with this, I'm definitely going to write my browser React-like library. This is fine, but there is an issue. Okay, some functions only really apply to ftext or fhtml. Now that this is a sum type, they'd have to result in a maybe. Let's avoid this by splitting the sum type into separate types. Okay, so we have a data text, which is a text string. It's pretty simple. And then we have a data HTML, which is HTML, which takes properties and children. Yeah, okay, the problem here is that children could be text too. So we can do this. What's the type of our children? It could be either. In fact, it could probably be anything that implements the following class, allowing us to render a DSL as an HTML string. Class renderable component, where render is a function that goes from component to string. Okay. Okay. Write a type for the children. So yeah, data HTML, just properties, string, and then as a children, which is still gonna be an array of what? It's gonna be an array of stuff that can be renderable. Not entirely sure about this. We need to make this rank 2. Legal polymorphic type. GHC doesn't yet support predicative polymorphism, which I have no idea what it is. Well, we can do this. Okay. So, chiroptical, is it how you spell it? Do you have any opinion on this? I'll try looking at B, maybe it will give me clues on how to solve this. Now I'd really like to do what I'd really like to do, where rendering is fmap over the children with render. What's stopping me? Fix it. The full error is that GHC doesn't support predicative polymorphism. So I think there is something very wrong with what I wrote. No. we can try this. No, that's it. Uh, so let's try make it a single child for now. Okay, with a single child, I don't get the error. Does oh, maybe it has to be like this. Ah. Yeah, makes much more sense now. I had too much stuff inside the array constructor, list constructor. Okay, this type checks now. I'm not entirely sure that it's the correct answer. So obviously JHC was complaining because I was putting the for all and the constraint inside of the array list constructor, and that's something that's not possible to do apparently, and I don't even know if it makes any sense at all. This makes much more sense, obviously. So we have children, which are a list of components, and the only thing we know about these components is that we can render them. That's all. So component is an existential type. Okay, so what I really like to do when rendering is fmap over the children with render. What's stopping me? Fix it. Okay, let's try writing this function and see what the error is. So we can render, goes from HTML to string. Let's make it simple and ignore the properties for now. Of course, we need to implement the instance renderable text, where show text s equals s. So we need the renderable for HTML2 for sure. This is render. I guess we can do something like this. C. This, and then we can append map render C. I'm getting some errors. Sorry, this is pn property name, property value. This is obviously an array of strings, so we can why doesn't it work? Isn't comma t to get the type of a function? Type maybe I need parentheses. Ah, come on. Why isn't this working? What am I doing wrong? Maybe the stack REPL doesn't allow to search like this for types. Yeah, I just don't remember what's the function to concatenate mconcat first, maybe. But do you know how, if it's possible in the stack REPL to search, to do a type-driven search? Because like, this doesn't work. Do you mean the website, or there's a Google command here? Oh, that sucks. I remember doing it, maybe it was with PureScript. Maybe it's possible to do this in PureScript and not in Haskell, I'm not sure. Well, anyways, we're getting a new error now. Yeah, also in Unison. Okay, so a render has an error. Ambiguous type variable component 0 arising from a use of render prevents the constraint renderable component 0 from being solved. Probable fix: use a type annotation to specify what component 0 should be. Yeah, I guess so. Not entirely sure how to fix this though. So it says that it's ambiguous. Isn't that the point? Because we want to be either the HTML or the text component. Oh wait, do I have to? No. Okay. This was a random guess. Didn't work. Ambiguous type variable component 0, arising from the use of render. So what it's saying, it doesn't know which instance of this patch here. How am I supposed to help GHC to figure this out? Maybe we can write an helper function. Where we can explicitly write the types. Role component goes from a list of component to a list of string. It's still not working. Nothing changed. I'm still getting the same error. Let's read the questions here. Maybe give us some clues. Yeah, that's the problem with these kind of things. It's really hard to keep them fresh. Now that we're an established Haskell shop, we would also like the option to render our HTML to a Shakespeare template to write to a file. Yeah, well, this is easy. You could just pass a function. that allows to choose the type of output, but that's not gonna help us now. So the problem is that I'm not 100% sure that this is correct. So it could be that the error, we have this error because I did something wrong here, or maybe because I did something wrong here. I'm honestly completely stuck here, so I feel like I'll cheat. I'm gonna cheat for this one. Let's check the answer. I don't want to scroll too much. Oh, we can check the one we already did. Okay, this is correct. Looks correct. Looks correct. Yeah, the right thing here. Looks correct. Let's see. If you can go from our parent input to a child input and from the child output to the parent out, do we really care about the child inputs and outputs? Probably not. Like initializing them, we don't have to keep track of them in types. Yeah, got this right. Okay. So we have a data child which goes from renderable. Okay, I'm not sure if this kind of writing it this way is gonna make any difference, but I'm gonna try and see if there's any difference. So we have a data child. Was it? Yeah. Child renderable a child, and this becomes an array of child. And this works. No, doesn't work. Sorry. Yeah, it works. I don't know what to think about this. I don't know what to think about this. So our old stuff was something like role component, renderable component. So I wonder if this is useless right now. Do you mean here from the render children or here from the child data type? Well, it's still RankNType-ish because we have an existential type here, which from what I got, it's kind of like having a rank2 type variable in a function. What I don't get is why it works like this and doesn't work like this. Which I guess, I mean, this for all component goes from here to inside the child, but yeah, but why? I mean, if I don't get why this is happening, and if by not getting it, next time maybe I stumble into something like this, I won't be able to solve it unless I remember this very specific case. Say, oh, that time I used a data type JDT with an existential variable and it worked. I'm gonna ask it on a Slack channel later on, probably. What was the error here? Okay. B was type component 0. Arising from can decide which instance to use. Just taking some notes, I'm gonna ask on the channel. Maybe someone will be able to answer me. Okay. Did they give any explanation here? Not really. That sucks. Yeah, and this one is easy. You can just have add a new to Shakespeare, goes from component to some data type, and then we have to add. Oh wait, do you have the solution? Oh, makes sense. Makes sense. So what I was trying to do before by putting the for all inside of the array was actually correctish, except for the fact that GHC isn't able to work with that. You're right. You're right. This way, yeah. How I wrote it this way was that the component had to be the same. And then obviously it couldn't happen because we are passing different children. While here each children is its own component. Makes sense. I'm not sure if it's the correct answer technically, but makes enough sense for me to remember. Thank you. Thank you very much. Yeah, I always put question marks at the end too. I think it's tricky for everyone. Okay, so we did 5. Let's go with 6. And we still have 7 and 8 afterwards. I hope they don't get harder and harder because I'm already struggling at 5. Remember our all good mystery box. So we have a mystery box. Okay. Ready seeing this data type. Another at least 2 exercises, I think. Knowing what we know about RankNTypes, we can write an unwrap function. Write the function, and don't be too upset if we need a maybe. Okay. So this is gonna take a function, mystery box A, So I'm writing this, but then I'm writing, do we really need RankNTypes to write this? F wait. Doesn't make much sense. Oops. Unwrap mystery. Oh. I don't know. I'm just putting it down, trying to make it type check. We wrote unwrap functions. That was what I asked myself at first, because we need an F because all these constructors can have different types, right? Why does it have to be rank 2? Can we write something more like we are taking out the value of the box. I don't know, I'm actually confused. So let's check, because we already wrote some unwraps for this mystery box. Yeah, we tried to write it here, but it was impossible. And it should be possible now. So for example, we can write an unwrap mystery box, which goes from a mystery box A. Can we write something like this without RankNTypes? Well, I mean, the point is that we have to use some kind of rank2 function, otherwise it would be pointless to have it here. So there has to be something more complex. So I'm trying to figure out what are we supposed to do. So I think what's going on is that by using this function, we are able to delay the output type. Doesn't make any sense. A mystery box int contains a type int. I don't know. I think the type is correctish. I can try using it and see what happens. Mystery 1 can be a mystery box int. Mystery 2 is gonna be a string box. Oops. Oh, come on with these eyes. Okay, let's say we have these two boxes. So I can unwrap mystery box, mystery 1. I can unwrap mystery box. I'm so annoyed by this. Mystery with a Y, with a Y. Mystery 2. I can do this. It's mystery with the I for me. So okay, this type checks for now. So now let's try using a wrap mystery box. So it's gonna have a function. Which can be unwrap mystery box, mystery one. I don't know, the function I wrote looks pretty pointless. I mean, it's just adding an extra step to this function here. Yeah, I'm not sure about that type at all. I'm just trying to see if it makes any sense by trying to find usages for it. So let's say our function unwrap mystery box is like this. Can we do something like oh yeah, we can do this because I think I'm using the standard Emacs mode right now because yeah, because I had Haskell in the engine before and it suddenly broke completely and it wasn't working anymore. So I just moved to the standard one. You know, it works well enough here. This is just a virtual machine I have on my gaming PC at home, so I didn't want to waste too much time trying to make it work. Also because Haskell in the engine and language server take ages to compile. So I feel bad about that. I think I will have to cheat for this one too, but I really don't want to. This function is completely... Yeah, this PC is not very powerful, and also I only have 16 gigabytes of RAM, and since it's a virtual machine, I can use all of them, so it's not the best, but it works. I don't know. I mean, at that point, I might look as well, right? Okay, let's try giving me a hint. I'm gonna go grab some water very quickly.
Mic off. Mic on.
My signature is essentially correct, but remove the inner maybe. I don't know if you're helping me or I'm just confusing me much more now. Okay, but I don't know. It feels weird. Basically, the F no longer dictates the return type. I'm not entirely sure what you mean, and also I'm not sure. I'm gonna look at the solution. This is confusing me too much. Too late. Okay. I'm still not entirely sure. It's fine because even now that I'm writing it, I don't really still don't understand the point of this. Let's make it prettier. Yeah, it doesn't make much sense anymore. So what's the point of this function now? So we have this unwrap mystery box, which takes a function that goes from a mystery box I to O. Takes a mystery box of A and returns a maybe O. So why does it have to wrap it in a maybe? Because the empty box doesn't contain anything. That's the only reason why. Otherwise, it applies the function to the value of the box. Okay, this makes sense, but how do we use this in a way that's more useful than something like this? Yeah, the empty has nothing inside. So, for example, oh, but yeah, I think part of this issue is that I'm mistaken what a wrap should do. A wrap shouldn't return the value of the box, but should return the inner box. That's the problem. Makes much more sense now. Makes much more sense. So, for example, we can't write this one because this has to be like from mystery box A to mystery box B. The nothing here means that we can't wrap an empty box because there's nothing inside. So this is not possible to. We can write this anyway because the only thing we can do is write some very specific function. So we can write from mystery box bool to mystery box string, and then we can write a version that goes from mystery box string to mystery box int, but we can't have a generic one. This way we can have a generic one, right? And do something with that box. So let's try writing something, for example, wrap mystery box. Some function, and we can pass mystery 2, and then here we can do like +1. Oh, this function takes a box and returns. Yeah, So it's a little clearer this way. So basically what this unwrap mystery box allows us to do is to take any kind of box and pass a function that does something with the inner box. Yeah, it's a very convoluted example, not very intuitive. So maybe something different would have been more helpful, but so why do we need a maybe? There's nothing inside the empty box. Okay, thank you for watching, and thank you for your help. Uh, is it this? Uh, no. Because this unwrap mystery box B needs a function that goes from mystery box. Okay. Hmm. Starting to get a little tired. I can see that things are not getting to me very easily. F. We match expected type P with actual type char. P is untouchable. Okay. Where is P? Did I use P anywhere? No. I think probably the fact that I'm using this where with an F here is doing funny stuff with the variable quantification. Okay. What happens if I pass an empty box? Works. Why are you complaining? Ah, you're not as smart as you think, GHC. Then maybe I can do. Oh, okay. Don't care. Okay, works. It was a little confusing exercise. Way too much mystery involved into this. Sorry, just 5 seconds.
Mic off. Mic on.
Okay, let's move to exercise 7. I will try, and if I'm to try to even understand what's going on, I'll call it today. I really wish I could finish with the RankNTypes. So when we talked about data kinds, we briefly looked at the SNAT type. This was hard. So we have SNAT, which takes type n of kind nat, and has the constructor as z, which is SNAT of type z, or a successor, which takes an SNAT n and returns SNAT of a successor of n. Okay. We also saw that we could convert from an SNAT to a NAT. I should already know this one. Okay, yeah, this was easy. Okay, how do we go the other way though? How do we turn a NAT into an SNAT? In the general case, this is impossible. The NAT could be calculated from some user input, so we have no way of knowing what the SNAT type would be. However, if you could have a function that would work for all as not values, if you implement the from not function, it should take a nat along with some as not accepting function, maybe at a higher rank, that returns an R and then returns an R. Successor case is a bit weird here. Type holds will help you. If you're looking for a property that you could use as your function, remember that from not x to not equals x. Yeah. Okay. From not takes a nat. Takes a function. Okay, this function, which take a nat returns an R. Still not sure what I'm writing, just going with it and see where the types takes us. Why does this function need to be return a nat into an s nat? In general case, it's impossible. Not could be better from or if we would have a function that would work for all as not values. Implement the from not function. I'm very, very confused right now. It should take a nat along with some as not accepting function. So why is this from not, which should return an s not, returning an R? I guess that's because we so like this. Okay, makes sense. The successor case is a bit weird here. Type holds will help you. Will they? Oh, this is the successor one. Okay. A, this is a NAT. Right. Could it be F of SS from NAT N? Oh yeah, this is R. So we have a function that goes from A to B. A function goes from A to A. I guess we can do this. Okay, it seems to work. I mean, at least this type checks. Now the problem is, how do we use this? And the second problem is, does this work? How are we supposed to use this? So let's say that we have 2. What is this function supposed to be? Oh, sorry. This. Found the hole. Yeah, you're not helping me, man. You're not helping me at all. No, I'm not gonna look at the solution. I have to do it. Oh, let's see if this gives us an hint. From nat x to nat equals x. Okay. Test from nat nat is sc to nat equals sc. Deriving q. Okay, works. Let's print as nat. It's not an not sorry, string. Let's use a different symbol. Okay, so it makes sense. We can convert. But we need to be able to accept a function that does something with this value. Because from nat, since this is a rank 2 type, I'm so tired. Let's go back to the recap. Rank 2 type, the code gets to choose. Okay. So it's from nat gets to choose, and then we can't use it to figure out what the snat is. So the only thing we can do is from here tell the caller, okay, you can pass me a function that from any snat produces something else, and I'm gonna use it. And we're using it with this print. Okay, cool. This was easier than the last one. 8. Bring our vector type back once again. Data vector, n is a nat, a is a type, sorry, n is a type of kind nat, and a is a type of kind type. Where vnil is a vector of length 0, and vcons is a vector of length greater than the vector we are consing to. It would be nice to have a filter function for vectors, but there's a problem. We do not compile time what the new length of our vector will be. But does that ever stop us? Make it so. Okay. Filter v. This one takes a vector, some length n of elements a's. So it's gonna take some function here. and it's gonna return another vector of a different length. Probably not. Probably have to return something else here. And then here you can say for all I don't know. Going very randomly right now. Feeling very tired. So, filter function for vectors. We're not actually filtering our vectors here though, right? Do we also need a function that goes from A to bool? So if you have a v-nil it's really hard to work with this kind of abstractions, I feel. Maybe because I'm not working with an actual problem. I don't know. Filter V. Now we have beacons. A value. And then we have the rest. Now this doesn't make any sense, right? This doesn't make any sense because I'm using the predicate on A, but then what am I gonna do? So this is wrong. This is definitely wrong. So this from nat took a nat, then took a function that changed as nats to something else or returned something else, because we couldn't return as nats directly because we have an idea what this n is. So here we have a vector. We take a function that filters vectors. And here we'll be returning, ideally, it would be possible, something like a vector MA, but this is not possible. So what we need is a function that does something with this vector. Kinda makes sense. No, not a solution. Oh, wait. It's more this, right? Because this is already a vector. It's not an element of the vector. Okay. So then we have a filter vcons, we have a predicate, we have a function. It's probably gonna be something similar to this, right? So filter v, taking the rest of the elements, taking the predicate, and doing something here. So if PA is true, then we keep this element. Otherwise, we don't keep it. So we just use F. Let's see, because GHC hasn't been very helpful lately in these latest chapters. Found a hole. Choose from vector MA to R. Not helpful at all. We're composing F with the successor there. So we can compose F with V cons A. Type checks. That's right, because I'm not sure at all. So we can write a vector which is gonna be v count 1. This is not heterogeneous, right? I can do this. No, I can't. V counts 2. V counts 4. V counts 6, 7. V nil. Okay. And then we can write a print vector which takes a vector and let's make it simple. And this. Do we have this? Intercalate is not scope. Intersperse maybe. Bar data list intersperse. Sorry, intercalate was fine. Print in nil. Yeah, it's empty string. Now beacons as. Let's show a. And inner goes from vector int string. No, sorry. To an array of string, list of strings. Was it complaining? I'm so tired. Things are getting harder and harder. Okay. And now we can do and final. And it's gonna be a filter v of our vector 1. Our function is gonna be bigger than 3. And then we're gonna have a print vector. Oh, it works. It works. I'm so happy. So let's try going again, because I know I wasn't very talkative. Anyways, so we have this vector. We want to write a filter function for this vector. The problem is that we have a vector which has an encoded length, and we can return a vector with a different encoded length as our output because we need dependent types to do this. Right? So what we can do instead is also ask for a function that is able to work with a vector of any length and do some stuff with it. This way we can write our filter function. So if we have a vnil, we just apply our function to the vnil. And if we have vcons of as, or predicate our function, we just filter the rest of our function with our predicate. Now we change our function. So if the predicate holds for this value, we apply vcons a. We combine f with vcons a. Otherwise, we just apply f. So this way we are rebuilding our list with a prepended f. And we are able to use it. So we have a vector. We wrote a print vector which prints a vector. It's pretty self-explanatory. And this way we're able to filter our vector, taking only elements that are bigger than 3, so 4 and 7, and printing it. So we are not able, I mean, the only operations we're able to do with this vector are operations that sorry, we can return a vector here, but we can do stuff with the vector that's returned by filter b. So it's a little mind-bending. Hope doing these exercises made me keep this thing a little clearer, and I won't forget them next time. Hope they're a little clearer for you too, if you're watching the VOD afterwards. Thank you for joining the video, the stream, to everyone. I went on for 3 hours. That was way too long. Good night, everyone.